Welcome back, Algebra 2 students. Here you will see your lesson for today. And if you're Algebra 1, you may go ahead and just pause the video and just end it because this part is not for you. But anyways, Algebra 2 students, what I want you to do at this very moment is I want you to take out your lecture notes and go ahead and get started. The very first thing that we're going to do is we're going to write down some definitions. We're going to start off with an exponential function. You've learned what a linear function looks like. You've learned what an absolute value function looks like. You've learned what a quadratic equation looks like. You've learned what a cubic equation looks like, right? Every single type of equation has different types of forms. Now, an exponential function is of the form y equals a times b to the power of x, where a cannot be equal to 0, right? So because if a were 0, 0 times anything will be 0, right? So obviously this is not possible. And b is called the base, right? This is the base, and it has to be a positive real number other than 1. Now, someone may be asking, like, can b be negative? Now, b can't be negative because that equation would not be continuous. Now, continuity is something that you're going to learn at a later part of your mathematics career, but just keep in mind that b must be positive. Okay, so go ahead and start writing down the definition in your notes, right? You're going to write down an exponential function is of the form. Now, I want you to go ahead and write down. I am not going to be doing this every single second. Taking out this lecture notes tab and writing down everything that I want you to write down. The main reason why I'm not doing that is because, well, first of all, it's going to take up a lot of time. Secondly, it's big and bulky. It doesn't look so good. I'm pretty sure once I explain to you in the video, you can pause the video and just take a second to actually write things down, right? So that is what an exponential function looks like. That's what we're going to be dealing with now. Now, there's certain conditions. If a is greater than 0 and b is greater than 1, then y equals a times b to the power of x is exponential growth function. Well, what are some examples of that? Say, well, most of the time the equations that we're going to be dealing with is where at the beginning is when a is equal to 1, so you're only going to have the base, right? So that base says equal to more than 1. What are some examples of numbers more than 1? Let's say 2, 3, 4. What are some fractions that are more than 1? 4 over 3, 5 over 2, right? These are examples that are numbers of over than 1. You may also think of decimals, right? 1.5, 1.3, 1.1 is technically still over than 1. So any number that is over than 1 with the b, sorry, not just any number, specifically the b, will be exponential growth. Now, when that is the case, this b is now called the growth factor. So this is the very first thing that I want you to write down is, first of all, I want you to draw this. You don't have to be that perfect. You can just go ahead and draw an x and y graph with a line kind of curving up. And this right here is called exponential growth. Now, obviously, the opposites would be exponential decay. And you see the function going in a downwards motion, right? Now, one thing that you're going to learn also later on is going to be called an asymptote. I'm just going to explain it real quick. I don't want to be go that into specific or be that like formal about it, but an asymptote is a line that a graph approaches more and more closely. So, say for example, in this case, y equals 0 is the asymptote, right? So this line will get closer and closer and closer to y equals 0, but it will never touch it. Now, some may be wondering, at some points, this line is so close to it, it runs parallel, right? Well, no, it doesn't run parallel because the line keeps getting closer and closer. Now, the only reservation is that, like, it will never, ever touch it, right? That's the point of an asymptote, is that these are like boundaries. These are things that are not allowed. Now, let's go ahead and write down a definition for exponential decay, which is the following. Say a is greater than 0 and b is between 0 and 1. So very specifically between 0 and 1, then the exponential function y equals a times b to the power of x is called an exponential decay. So what are some examples of numbers between 0 and 1? Well, a lot of you can think of decimals like 0.5, 0.6, 0.7, 0.9, right? You can literally think of anything. Now, you may also consider fractions. 2/3 is technically less than 1, right? 4 over 10 is less than 1, right? So just keep in mind, if you have a number between 0 and 1, you have an exponential decay. Now, that means that this case, the base is now considered or is called a decay factor. So B actually has three names. If you think about it by now, we said that B is the base. But if B is greater than 1, then it's called growth factor. But if B is between 0 and 1, it's called decay factor. So just keep that in mind. I also want you to draw this out. I want you to know what a exponential decay function looks like. So go ahead and pause this video so you can go ahead and draw a good representation of it. Now, for the example that you are going to show me is you're going to tell whether the function is exponential growth or exponential decay. At this moment, I am not going to require you to graph the function because this is going to take some more time, and I'm thinking about doing this lesson on decimals, so just consider omitting that. But can you tell whether or not it's growth or decay? So we see the first example. Here we see the base is 2. Now, is the base greater than 1 or is it between 0 and 1? So obviously we all know that 2 is greater than 1. So by definition, this will be exponential growth. All right, let's see if the solution takes us that way. Same definition, look at that. The base is greater than 1, so the function represents the exponential growth. Now, let's go look at the second example. It says we have the exponential function y equals 1/2 to the power of x. Now, 1/2, a lot of you know that 1/2 is less than 1. Now, be very specific with how you say this. It's less than 1, but technically a lot of numbers can be less than 1. Remember that it has to be between 0 and 1. So yes, 1/2 is between 0 and 1. Therefore, this is called an exponential decay function, right? We see that right here. Look at that. The base is 1/2 is greater than 0 and less than 1. Therefore, this function represents exponential decay. So you're going to be showing me that you learned what exponential growth and exponential decay functions are by doing these examples on Schoology. I have posted all of these and your assignments on Schoology, so go ahead and get started. Good luck.